In this video, we are going to talk about how to integrate rational functions. So let's evaluate this question, which is integral of x cubed plus x divided by x minus 1 dx. So to be able to integrate this function, the way we need to go about this is to first express this in partial fractions. Then we can use the partial fractions to split the function into the various partial fractions and integrate. So now you can see that this is the case of improper fraction. And if we divide the highest power in the numerator, which is x cubed, divided by the highest power in the denominator, which is x, we are going to get x squared. So now let me take this out. So we can write x cubed plus x divided by x minus 1 as equal to, we need to have a constant a multiplied by x squared plus another constant b multiplied by x, then plus a constant c, and then plus d divided by x minus 1. I have already done a video on this. I will link it in the description so you can watch that video if you did not previously understand how to resolve rational functions into partial fractions. So now the next thing we need to do is to find the lowest common multiple, which is x minus 1. So this implies that ax squared is going to multiply x minus 1 plus bx, which will also multiply x minus 1, then plus c multiplying x minus 1, and then plus d, since d has a denominator x minus 1, that will not multiply anything. So now let's proceed. So this is equal to x cubed plus x divided by x minus 1. So since the denominators are equal, then we can equate the numerators. So it implies that ax squared then times x minus 1 plus bx times x minus 1, then plus c times x minus 1 plus d is equal to x cubed plus x. So the next thing is to rewrite this as a then times x squared times x is x cubed, then x squared times minus 1 is minus x squared, then plus b, x times x is x squared, then x times minus 1 is minus x, then plus c times x minus 1 plus d equals x cubed plus x. So you can see that on the left hand side, the only place where we have x cubed is here. So you can see that outright a is equal to, now the coefficient of x cubed here is 1, so a is equal to 1. Now apart from that, we have x squared here, we have x squared here, and none anyway. So we have a and then plus b is equal to, now the coefficient, there is no x squared here, so that would be 0. So this implies that a is equal to minus b. So if a is equal to 1, then it implies that b is equal to minus 1. Now apart from this, we also have x here, and then we have x here. So now we know that b plus c is equal to, now the coefficient of x here is 1, but we know that b is equal to minus 1. So minus 1 plus c is equal to 1, and therefore c is equal to 2. And then now we know that there is no x here and there is no x here, which is c plus, here is minus 1, so minus c then plus d is equal to 0. So this implies that c is equal to d. So if c is 2, then it implies that d is also equal to 2. So now this partial fraction can be, which is x cubed plus x divided by x minus 1, can be written as equal to ax squared, which is a is 1, so 1 times x squared is x squared, then plus b is minus 1 times x is minus x, and then plus c is equal to 2, so plus 2. and then plus d. D is also equal to 2, so plus 2 divided by x minus 1. So now, this means that this integral can therefore be written as, which is integral of x cubed plus x divided by x minus 1 dx, can be written as integral of x squared dx minus integral of x dx plus integral of 2 dx, then plus integral of 2 divided by x minus 1 dx. So now let's continue. So this is equal to, if you integrate x squared, you get 1 over 3 x cubed. Now minus, if you integrate x, you get 1 over 2 x squared. And if you integrate 2 dx, you are going to get plus 2x. Now it's left with this one, which is integral of 2 divided by x minus 1. The way to go about this is, now let's do something here. If you integrate 1 over x, what is it? Now the way to go about this is differentiate the denominator. If you differentiate the denominator, you get the numerator. Then the answer is equal to natural log of the denominator, which is x, then plus c. So for example, if here was integral of 1 divided by x minus 1, if you differentiate x minus 1, you get 1, which is the numerator. So this is equal to natural log of absolute value of x minus 1 plus c. But in this case, it is 2 divided by x minus 1. So we need to factorize 2 out so that we'll get 1 divided by x minus 1. And if you factorize 2 out, and then you integrate 1 divided by x minus 1, you're going to get natural log of x minus 1, absolute value of x minus 1, then plus the constant of integration c. So therefore, integral of x cubed plus x divided by x minus 1 dx is equal to 1 over 3 x cubed minus 1 over 2 x squared plus 2x, then plus 2 natural log of absolute value of x minus 1, then plus c. So solve integral of 1 divided by 1 plus 2 exponent x minus x dx. Now what we will do is that, let me rewrite this. We can rewrite this. So let me first write the function, which is 1 divided by 1 plus 2 exponent x minus exponent minus x dx. So the way to go about this is, now let's multiply both the numerator and then the denominator by exponent x divided by exponent x. Now exponent x divided by exponent x is 1. 1 times any number is that number. So in essence, we are not changing this function in any way. And if we do that, we are going to get integral of exponent x divided by, now exponent x times 1 is exponent x. Exponent x times 2 exponent x will give us plus 2 exponent 2x. And then exponent x times exponent minus x is 1. So here becomes minus 1 dx. Having gotten this, then what we'll do is that, let's say, let a, capital A, to be equal to exponent x. So it implies that the a is equal to exponent x dx, which is, if you differentiate exponent x, you get exponent x dx. So this means that dx is equal to dA divided by exponent x. So now this integral, which is integral of exponent x divided by exponent x plus 2 exponent 2x minus 1 dx, can be written as equal to exponent x, then dx in this case is times dA divided by exponent x, then divided by, now remember we said let a to be exponent x, so here will become a then plus 2 exponent 2x can be written as 2a squared and then minus 1. So this exponent x and exponent x can cancel out. So this integral becomes integral of the a divided by 2a squared plus a minus 1. Now you can see that this integral now looks like it's now in a form that we are very familiar with, which is the partial fractions. So 2 times minus 1 is minus 2. So we are going to look for two numbers that if you multiply, you get minus 2, but if you add, you get 1. So those numbers are 2 and minus 1. So this integral can therefore be, so the integral becomes the a divided by 2a squared then plus 2a minus a minus 1. And this is equal to integral of the a divided by, and let's factorize 2a out, 2a and a plus 1 then minus 1 a plus 1. So this becomes integral of the a divided by, to one bracket, 2a minus 1 then times another bracket, a plus 1. So you see that now this is in a form that we are familiar with. So what we'll do is that let's take this function and then express it as a partial fraction. So we have been able to express the integral, which is 1 divided by 1 plus 2 exponent x minus exponent minus x dx, as 1 divided by into bracket 2a minus 1 times a plus 1 dA. So let's take this rational function and then resolve it into a partial fraction. So we are talking about 1 divided by 2a minus 1 in one bracket then times another bracket a plus 1. So this is equal to a divided by 2a minus 1 then plus b divided by a plus 1. So the LCM here is 2a minus 1 and times a plus 1. Then a will multiply, here is divided by 2a minus 1, so it will cancel this. So a will multiply a plus 1 then plus b. B is also going to multiply 2a minus 1. Then this is equal to 1 divided by 2a minus 1 in one bracket times a plus 1. Since the denominators are equal, we can equate the numerators, which is a times a plus 1 then plus b times 2a minus 1. Then this is equal to 1. So now, so just for clarity's sake, let me change this numerator, which is a, to a letter that is not known, like c, so that here will be c, so that we can differentiate this a from the original a. So this is c. Now, so you can see that we have a here and then we have a here. So it means that c plus 2b is equal to 0, and therefore c is equal to minus 2b. So this is our equation 1. And then here has got no a attached to it. So it means that c minus b is equal to, now here too has got no a attached to it. So that's equal to 1. But we know that c is equal to minus 2b. So we have minus 2b minus b is equal to 1. So minus 3b is equal to 1, and therefore b is equal to minus 1 over 3. Apart from this, we know that c is equal to minus 2b. So c, which is equal to minus 2b, becomes minus 2 times b. b is minus 1 over 3, and therefore c is equal to 2 over 3. So in terms of partial fractions, this function, which is 1 divided by 2 bracket 2a minus 1 times a plus 1 is equal to c, the constant c, and c in this case is 2 over 3. So 2 divided by 3 times 2a minus 1. And then apart from this, plus b. B is minus 1 over 3. So minus 1 divided by 3 times a plus 1. So this means that this integral, which is integral of 1 divided by into bracket 2a minus 1 times a plus 1 dA is equal to integral of, which is 2 over 3, integral of 1 over 2a minus 1 dA minus 1 over 3, integral of 1 divided by a plus 1 dA. So we've been able to reach this point. So at this point, we can easily integrate this. Now, let's take this. If you differentiate the denominator, 2a minus 1, with reference to a, you are going to get 2. So because the numerator is 1, what we will do is that we will push these 2 inside, so that this becomes equal to integral of 1 over 3, 2 divided by 2a minus 1 dA, minus 1 over 3, integral of 1 divided by a plus 1 dA, so that this part will become 1 over 3 natural log of the absolute value of 2a minus 1. You see that if you differentiate 2a minus 1, you get 2, and minus 1 divided by 3. Now if you differentiate a plus 1, you get 1. So that becomes natural log of the absolute value of a plus 1 plus the constant of integration c. Remember that we said let a to be equal to exponent x. So therefore, we need to replace wherever we see a with exponent x. So the integral of 1 divided by 1 plus 2 exponent x minus exponent minus x dx is equal to 1 over 3 natural log of absolute value of 2 exponent x minus 1, then minus 1 over 3 natural log of the absolute value of exponent x plus 1, then plus the constant of integration c. Evaluate integral of 5x squared plus x plus 6 divided by x plus 1 times into bracket 2x squared plus 3. So this is the same thing. So let's take this rational function and express it as a partial fraction. So the function is 5x squared plus x plus 6 divided by x plus 1 in one bracket and times another bracket 2x squared plus 3. So this is equal to, now you can see that this is the form of a quadratic. The denominator has a quadratic term in it, which is the 2x squared plus 3. So this is equal to a divided by x plus 1 and plus this side, which is bx plus c, divided by 2x squared plus 3. So let's find the LCM, which is x plus 1 in one bracket times 2x squared plus 3 in another bracket. So a is going to multiply 2x squared plus 3 and plus, now one bracket bx plus c, and that will multiply x plus 1. So x plus 1 here. So this is equal to 5x squared plus x plus 6 divided by one bracket x plus 1 times another bracket 2x squared plus 3. So since the denominators are equal, we can equate the numerators. So it implies that a times 2x squared plus 3 plus 2 bracket bx plus c times x plus 1, and that is equal to 5x squared plus x plus 6. Now let's expand. So we have a here in one bracket, then 2x squared plus 3, and then plus, now bx times x plus 1, then plus c times x plus 1. This is equal to 5x squared plus x plus 6. So a times 2x squared plus 3 plus b, then x times x is x squared, x times 1 is x, plus c times x plus 1. This is equal to 5x squared plus x plus 6. Now, see, there is an x squared term here. There's also another one here. There is another one. So it implies that 2a plus b is equal to 5. So this is our equation 1. Now, there is also an x term here and an x term here. There's another one here. So b plus c is equal to the coefficient of x here is 1. So this is equation 2. And then this term, which is 3a, and then this term plus c equals 6. So this is equation 3. So let's rewrite all these three equations and then solve them simultaneously. We have the first one, which is 2a plus b is equal to 5. So this is equation 1. Then b plus c equals 1, equation 2. Then the last one is 3a plus c is equal to 6, equation 3. Now, from equation 1, we can make b the subject and say that b is equal to 1 minus c. So this is equation 4. So let's put equation 4 in equation 1. So 2a then plus b, which is 1 minus c, equals 5. So 2a minus c is equal to 5 minus 1, which is 4. So this is our equation 5. Then now let's write equation 3 beneath it. Equation 3 is 3a plus c equals 6. So this is equation 3. Now minus c plus c, if we add, it can go to 0. So let's add equation 5 and equation 3. So it becomes 2a plus 3a, which is 5a. Minus c plus c will go to 0. Then 4 plus 6 is 10. So now we can see that outright a is equal to 2. Now that we found the value of a, we can put that in equation 5 and then find the value of c. So from equation 5, we see that it's 2a minus c equals 4. So 2 times 2 minus c is equal to 4. Now let's make c the subject. So c is equal to 4 minus 4. Therefore, we can see that c is equal to 0. So c is 0, but we know that from equation 4, b is equal to 1 minus c. So b is equal to 1 minus c, which is 0. And therefore, b is equal to 1. So therefore, we see that a is equal to 2, c is equal to 0, and then b is equal to 1. So this, in terms of partial fractions, can be written as, so let me write it here, which is 5x squared plus x plus 6 divided by into one bracket x plus 1 times another bracket 2x squared plus 3. This is equal to a is 2, so 2 divided by x plus 1, and plus b is 1 times x is x, plus c, but c is 0, so x divided by 2x squared plus 3. We are talking about integrating 5x squared plus x plus 6 divided by into bracket x plus 1 times into bracket 2x plus 3 dx. And we'll be able to express the rational function as 2 divided by x plus 1 plus x divided by 2x squared plus 3. So it implies that this integral becomes integral of 2 divided by x plus 1 dx and plus integral of x divided by 2x squared plus 3 dx. If we differentiate the denominator here, we will get 1. So therefore, let's pull these two out so that we'll get 1 divided by x plus 1 dx plus, now if we differentiate 2x squared plus 3, we are going to get 4x but the numerator is only x. So what we will do is that let's multiply through by 4 divided by 4. So 4 divided by 4. Integral of x divided by 2x squared plus 3 dx. So in next step, let's push this 4 inside. So we are going to get to integral of 1 divided by x plus 1 dx. Then plus 1 over 4. Integral of 4x divided by 2x squared plus 3 dx. So you see that if we differentiate the denominator, we'll get 4x. Therefore, we can write all of this as equal to 2 natural log of absolute value of x plus 1. Then plus 1 over 4 natural log of the absolute value of 2x squared plus 3 plus the constant of integration c. So finally, let's evaluate integral of 2x plus 1 divided by x squared times into bracket x plus 1 squared dx. So let's take this rational function and express it as a partial fraction, which is 2x plus 1 divided by x squared times into bracket x plus 1 squared. This is equal to a divided by x, because this is the case of repeated fraction. Then plus b divided by x squared. And then when we come to this, we have plus c divided by x plus 1 and plus d divided by x plus 1 squared. Now, if you don't understand this, get my previous video on how to express rational functions as partial fractions. You will understand all of this. I'll link it in the description. So now let's find the LCM, which is x squared times x plus 1 squared. So a is going to multiply. There is an x here, so to cancel one of this x. So a is going to multiply x. Sorry, let me rewrite this as ax times x plus 1 squared. Then plus, there's an x squared here, so b will multiply x plus 1 squared. Then plus c to multiply x squared times x plus 1. Then plus d, which will multiply x squared. So this is equal to 2x plus 1 divided by x squared times x plus 1 squared. So let's equate the numerator, which is ax times x plus 1 squared plus b times x plus 1 squared, then plus cx squared times x plus 1, then plus dx squared. This is equal to 2x plus 1. So let's push this x inside, which is ax. Let's expand. X squared plus 2x plus 1, then plus b. X plus 1 all squared is x squared plus, 2x plus 1, and plus c x squared times x plus 1, then plus dx squared equals 2x plus 1. So now let's push this x inside, which is a times x squared is x cubed. X times 2x is plus 2x squared. X times 1 is plus x. Then plus b times x squared plus 2x plus 1. Then plus c times x squared times x is x cubed plus x squared times 1 is x squared. Then plus d x squared. Then this is equal to 2x plus 1. Now, there's an s cube here. Then there's also an s cube term here. So it means that a plus c, there's no s cube term here, is equal to 0. And therefore, a is equal to minus c. So there's an s squared term here. There's another one here. There's another here and another here. So it means that 2a and plus b and then plus c plus d is equal to 0. Let's talk about the x terms. So this is equation 1 and this is equation 2. So if we talk about the x terms, there's an x term here and then none other place, and also there's also an x term here So a and then plus 2b is equal to the coefficient of the x term here is 2. And then when it comes to the terms without x, there's no other place except this term. So we see that b is equal to 1 and a plus 2b is equal to 2. So a is equal to 2 minus 2 times b, which is 1. Therefore a is equal to 0. But we've also established that a is equal to minus c. So this implies that c is also equal to 0. And then we know that 2a, so 2 times 0, then plus b is 1, then plus c, which is 0, plus d is equal to 0. So this implies that d is equal to minus 1. So in the end, a is equal to 0, b is equal to 1, c is equal to 0, and then d is equal to minus 1. So this in terms of partial fractions, which is, let me rewrite it here. So let me write it here. 2x plus 1 divided by x squared times x plus 1 all squared is equal to a is 0. So a divided by x will not stand, but b is 1. So 1 divided by x squared, and then plus c is also 0, so this term goes to 0. Then d is minus 1, so minus 1 divided by x plus 1 all squared. I'm talking about evaluating 2x plus 1 divided by x squared times x plus 1 all squared dx. And we'll be able to express this rational function as 1 over x squared minus 1 divided by, into bracket, x squared, x plus 1 all squared. So it implies that the integral, which is integral of 2x plus 1 divided by x squared times x plus 1 squared dx is equal to integral of 1 over x squared dx minus integral of 1 divided by x plus 1 all squared dx. So if we do this integral, so let's rewrite this as x exponent minus 2 dx and minus x plus 1 then exponent minus 2 dx. Sorry, there's an integral sign here. So if we add 1 to this, it becomes minus 1. So this becomes minus 1 over x. And if we add 1 to this becomes minus 1. So here becomes plus 1 over x plus 1. Then plus the constant of integration c. So it means that the integral of 2x plus 1 divided by x squared times x plus 1 all squared dx is equal to 1 over x plus 1 minus 1 over x plus the constant of integration c.